All right. Welcome everyone to the first lecture of Programming Fundamentals for 2021 in our exciting second year, well, third year technically of pandemic. I'm Dr. Luke Matheson. Luke is absolutely fine to address me with, but given that I spent all the time to get the PhD, I do like to write it down occasionally, especially on official forms. Make people get it right. All right. So this first lecture is going to be in two parts, basically. The most important thing is I have to get through some administrative material to make sure everyone knows kind of where you're at, what your assessment tasks are, where all the material is and stuff like that. Most of you already know already, despite the jokes in the chat. But hopefully I get through that relatively quickly and we get to do some actual programming, and we'll set you up a little bit for the second week. Okay, so let's start with the intro things. So first question is, why are we here? Hopefully everyone knows this, but you're here to learn to program, or to start to learn to program. This subject will get you a pretty significant way along that path, but it is a thing that takes years to decades to learn to be a good programmer. So when you get to the end of it and you say, oh, I'm not sure I learned all that much, you probably actually learned quite a bit. It takes a while to get really good at programming. It is a hard skill to learn. And it takes quite a change in mindset, unless you've already done it before, but then you've already got the mindset. And for a good chunk of people here, it's also one of the core practical disciplines of the degree that they're doing. So a lot of you will be Biscuit students, probably got a few software engineers, game design students, various other ones. But Programming Fundamentals also does attract students from other places. So sometimes science students, design, business and whatnot, who are interested in programming, but not necessarily required to do it later on. But as a skill, it is becoming more and more required, I would say, not just useful, but more and more required in a lot of other areas outside of what we would sort of narrowly think of as IT, especially science, engineering, of course, but things like design and business, at least knowing some programming is starting to be much, much more useful. And of course, it can also just be fun. It can be a thing that you like to do. I certainly think programming is, at least can be fun. Not every programming thing you do will be fun. Some of it will be boring. Some of it will be painful. Almost all of it you can learn something from though, but it can definitely be fun. So one question which has already come up in the chat is why pick programming fundamentals, basically? Why pick 48023? Because the School of Computer Science offers two introductory programming subjects. So Programming 1 and Programming Fundamentals. 41039 is Programming 1, in case you haven't figured that one out. The main difference in the two is a matter, the core thing is a matter of where you're going in your degree. So if you're, I think I've got that on the next thing. So neither have assumed knowledge, but if you're going to do a lot of programming and you're keen to get started, Programming 1 is probably the subject that you're more naturally a fit for. If you're particularly scared of programming, or you only want to do a little bit of it, or you want a slightly slower start, Programming Fundamentals is the subject for you. It's not that one is strictly speaking harder than the other or smarter than the other or anything like that. It's just that they're basically aimed at people who are coming in with different expectations of where they want to go with programming. So it's not a value judgment, it's just a better allocation of sort of how you spend the time with particular students. There are some differences though. So Programming 1, like I said, is aimed at students who are expecting to do a lot of programming. So probably are willing to put in slightly more work to get a bit further faster, because that will make some of the degree a bit smoother. By the end of the degrees, it's not going to matter at all. Like once you get to the end of the degree, there's no significant difference between starting in one and starting in the other. It's just kind of like a pacing curve, and programming one starts a bit faster. The other thing that programming one does is teach Java and Python alongside each other. So programming one is, broadly speaking, aimed at comp sci students, software engineers, those doing enterprise systems development, stuff like that. And those students need later in their degree both Python and Java. So it's a convenient place to start that process. Having said that, if you do programming fundamentals, you're still going to learn Java, and you're still going to learn to program, which is actually the skill that we're aiming for. The language is sort of, in some sense, neither here nor there, but having some consistency is good. But some, like if you're not doing the data analytics subjects at all, you'll probably need to never need to touch Python. So it's a bit of a choice. Having said that, I'm going to do my best to make materials, because I'm running both, make materials from each subject available in the other. So whichever one you pick, you'll get at least a little bit of a look at the other ones. So that's the broad breakdown. So some of you, you're perfectly welcome to ask questions about which one you should do. Post a thread, other people can read it and stuff like that. And I'll do my best to answer it. But again, there's not really a wrong choice, right? So if you pick one and stick with it, you're not going to lose out by the end of the degree or anything like that. You'll be in a slightly different place at the end of semester one, but it's not a massive problem. Right? So don't panic too much about which one you're in. Just kind of take your best guess, sort of. Unless you're in comp sci, then you're kind of forced to do programming one. Okay. The Zoom shouldn't be. Okay, I'll try and increase the capacity shortly. So in terms of how this subject will run, it's mostly going to use Ed, which again, most of you have seen already. So let me find the controls for this thing. So from Canvas, there's a link just here that takes you to Ed. It's as simple as that. Once you're in Ed, it dumps you in the discussion board. Where most of the sort of simple communication for the subject's going to be. So you can post questions here. You can post questions anonymously. I can ask it, all sorts of things like I can answer it. The other staff can answer them as well. Note, if you post anonymously, it's only the other students who can't see who you are. The staff still know who you are. And other than that, it works a bit of a mixture like Slack, Discord, Stack Overflow kind of thing. You can embed code in the posts in here, so there's lots of nice features, but we'll get to that later. So it dumps you in the splash pages of the discussion board. And like I said, this will be the main communication channel. The vast majority of the material for the subject is going to be in the lessons section. That's not meant to be there for the moment. Obviously, I can see a fair bit, well, a bit more stuff than you guys can. One thing about this subject is this is the first semester that I've taught it, and it's also the first semester it's going to kind of be completely in Ed, which means I am literally in the process of moving material from the old setup to the new one. So not everything is visible here at the moment. A lot of it's kind of hidden in slightly badly format stuff, but it'll appear as you need it. All of the lecture material is going to be here. For example, once this is recorded, this will be here. And let me unhide that now. And if you go to EdNow, we have a question thread for the lecture. So if, as you guys are coming up with questions, you can jump in here, leave it there. I'll do my best to look at it during the lecture if I can, but if I miss it, oh yeah, the chat's going to be recorded too. If I miss it, it'll be here later and it'll be public on the, visible on the discussion board, so everyone will be able to see it. It's where things like the lecture slides will be. Most weeks, I'm probably not actually going to use lecture slides. Like I said, this is where the recording will be. The other thing that you'll get is recordings from the previous version of this subject and programming one. So you can at least have a look at what's going on. Also, your lab material is going to be here. So the first lab is actually available now if you feel like going to look at it. You need to complete a prerequisite to get there. But essentially each week, depending on where we're up to, you're going to get some sort of material here. So the introductory stuff is fairly simple. This is the basics of programming, is just kind of more an ease in. Some information about whatever it is we're learning at that point. Maybe some additional exercises. Actually delete that one from there now. So for example, I would suggest that between now and next week's lab, obviously some of you only have the weekend, so it's not super crucial at this point. Have a look at the week one warm up, have a go at it, kind of get used to things. Everything to actually answer that week one warm up is in that learning material already. You may have to dig it out. So it might appear trickier than it actually is, but don't worry. In the week 2 lab, we'll actually get to playing around with it and you'll have a place to ask questions and so on and so forth. You don't have to do those activities before next week, but if you want to keep up with the subject, it's a good idea to keep on track. So the week 2 lab only requires that you, oh no, hang on, I'm going to switch that. Only requires that you've finished the introduction to Java. So you don't have to have done the week 1 warm up by the time you get to the lab. While we're here though, just to get a feel for things, if everyone can jump into Ed, go to the week 1 lecture and fill out the cohort survey. This is not compulsory. This is not worth marks or anything. This is just to get a bit of a feel for how the cohort is. While you're doing that for a minute, I'll see if I can let everyone else into the Zoom meeting. So I'm just going to mute myself for a second. Yes, I am muted. Sorry, I was just saying, for those who haven't noticed, the navigation for Ed is up on the top right here. So there's discussion is the first one, then there's workspaces, which we'll see in a moment. Then the lessons section, the analytics, and the admin. Okay, that is super annoying. So apparently the lecture has a limit of 300, which it does not say in the settings for it anywhere, and I can't change it at the moment. That's super annoying. It is recorded, so really no one's actually missing out on much here. They're just going to watch the recording later. But I would like everyone who wants to come to be able to actually come in. Yeah, if anyone is willing to live stream it, like recast it, go nuts. Just put a post on the discussion board and do that. If I can't fix this by next week, we might change the way the lectures are presented. As in, I might switch to a different casting thing and maybe do it straight to YouTube or something like that. I don't know if the UTS firewall lets me do it on Twitch, but I can see. We'll see. Anyway. All right. So So let's take a look at what everyone looks like here. So we've got a fairly broad spread of degrees here. You know, everyone's coming from different places. So everyone will have different backgrounds and different ideas of programming, what it does and how it's going to work. Mostly Biscuit and software engineering students, but well, actually there's something else is almost as big as well. So you've got quite a spread of people from across different cohorts in the university, I guess. Sorry, question there. The recording is posted on Ed, but if you're watching this, you will already know that. Almost everyone's in their first year, which is not super surprising, but what this says is that, you know, probably most of you, are coming in from high school, first time at university, lots of big, scary, strange things, new structures that you have to learn, confusing setups for everything because we can't just walk you all into classrooms of 30 anymore. More than half have programmed before, but not much more. Mostly Python, a few other bits and pieces. And there's all these people who've learnt 5 different languages before they get here. And a good percentage of you are nervous about programming. So what's the point of doing all that? So the whole idea here is to anonymously basically show everyone that you're not the only person here who is freaking out about programming. And like I said before, programming is scary. It is relatively hard to learn. I mean, you are learning a new language and it doesn't really conform to what you expect of language syntax stuff. If you've done a lot of natural languages before, you may find programming a bit easier, interestingly. But when you're sitting there working on this stuff and you've got, you know, a friend or an acquaintance or something who's going, oh yeah, that's easy. 1, it's not. 2, they're probably lying. And 3, you're not alone. So don't be afraid to reach out, talk to us. We're here to help. You're not the only one who's going to struggle with this. This is a hard thing to do. And we know that. That's the whole point of running the subject. If we thought this was easy, you wouldn't have the subject at all. That's why you do these things. You're doing hard, difficult things. And on top of that, it's a thing that's going to take more than one subject to learn. So most of you will do at least 2, maybe 3 or 4 subjects that focus just on learning to program. And even then, you're at best going to be a mediocre programmer. So unless you've already come in and you've been programming for years or something like that, if you're starting right now, by the end of university, you're probably going to be at best a mediocre programmer. And that is a good thing. That is not saying everyone who comes out of university is terrible. That's saying programming is hard. It will take decades to be a good programmer. And very, very few people become excellent programmers. Unfortunately, the ones who become excellent are the ones who make the most noise. So we get this skewed idea of how easy it should be. But programming is really, really hard. But like I said, don't freak out about it. We're here to help. That's the whole point of it. Okay, let me jump back to the lecture slides briefly. Too many screens. All right, so that's a very brief introduction to Ed. I'll go back to Ed in a moment and work with some stuff and highlight some of the useful features of it. So back to some of the administrative things. What will the assessment involve? Oh, actually, sorry, a good question has come and passed. So it's just how hard will it be to find a job if we're at that level? So I don't just mean you personally. Everyone who comes out of uni is at best a mediocre. It doesn't matter which university is at best a mediocre programmer. You, that is the like normal level of achievement, and it's one that you can perfectly reach with work. Like, so if you stick with your subjects and finish the degree, you'll be employable. You'll be as good as almost everyone else out there. There's a bit of a, like the same way that we do things with sort of celebrities and sports people and stuff like that. There's a bit of a cult of the elite programmer kind of thing. And we lionize people who can do ridiculous things with programming and then measure ourselves against them. And that's just not realistic. Right? So everyone who comes actually finishes their almost everyone who finishes their university degree, I should say. Technically, probably some people won't, but almost everyone who finishes will be perfectly employable. Don't worry about that part. Okay, back to the exciting administrative stuff. So what are the assessment tasks for this subject? So there's 3 basic assessment tasks. There are required lab exercises. You get one or 2 every week. So this, like, the vast majority of the material is coming from the previous version, but it has to be reorganized. So whether you get 1 or 2 will depend on how similar things were and stuff like that. But you guys won't have to worry about that bit. That's my problem. But you'll have some required exercises each week. They'll be clearly marked as required. You have to complete them by the end of the subject. So you can attempt them as many times as you want. You can get them wrong. You can mess them up. As long as you get them right somewhere along the way, you'll be good. So yeah, if you complete all of those required lab exercises, you get 50%. That is your basic pass level. So all those exercises are in Ed in your weekly lab. So when you've unlocked the weekly lab, you'll see the very first one here. This is the incredibly simple free pass, make sure everyone can get into Ed exercise. But you'll see here, I've marked it with a required exercise and it's got a big information block at the start saying, oh, yes, of course you can't see my Ed screen. This one. Yeah. Sorry. Go back to the lessons. Yeah. So for those who've unlocked the week 2 lab, you can look at it now, but those who haven't, you can see here there's an exercise which says required exercise. It's got a big thing saying this is part of your assessment, do it. The other ones, for example, don't. So they're just practice ones, things that teach you something. You need to complete it by week 12. There is a little complication there. If you want to have the additional exercises completed, then you have to complete them by week 10. So I'll get to the additional exercises in a sec, but if you want to do the additional ones, you have to have done the required ones slightly earlier. So to complete this one, I'm not going to complete it, but the submission for this is just, so it's a bit dark because I've got it in dark mode, but down here in the bottom right, there's a thing called the mark button. Every time you hit that, it makes a submission that is recorded and that we can look at. So all the submissions feed. So you can look at your own submissions. I can look at everyone's. You hit that, it makes a submission, it's recorded. You can submit these as many times as you want. There's no limit to that. You can keep trying until you get it right or fail to get it right, I guess. I very much doubt you will fail to get the required exercises right, because you can keep trying and you can come and ask us questions and we'll help you through them. But as long as you've got them done by the end, then you're good. Sorry, to Noah as well. It looks like 300 is the max. It's the most I can do at the moment. I need to go and talk to IT and see what the solution to that is. Like I said, anyone who's willing to restream this Other people, they can do that. Yeah. So if I can't get Zoom to be bigger, I'll do it in a different way. Actually, stop talking for a sec. I'm going to nick that Discord link. Chat, stop scrolling. Ah, got it. So let me just. So I assume this is not just going to rickroll someone. I don't know why you haven't suggested that already, but. Why did that not copy the? All right. Where was I up to? Slow network, excellent. That's right. It's talking about the submissions. So those are your weekly. It's not really a quiz. It's all going to be program exercises, but you have those weekly exercises. Now let's change back to slides. The other two assessment tasks are a programming assignment, which is just going to be a bigger thing that you have to build. To some extent, it's probably going to be broken up into a number of smaller tasks, but it'll be sort of a more continuous thing rather than like the little chunks you get in the lab exercises. Yep. So if you work hard on those lab submissions, you're done. You're passed. So if you do just the the required lab exercises, you've passed. That's the low hurdle to clear. So passing this subject is really straightforward. Just do those. That's it. Right. If all you want to do is get a pass in this, you're done. You'll be out of here done by week 10. So I don't actually know how many there are going to be technically at the moment because I'm working with the previous content and rearranging some of it. But basically you get one every week up to week 10. Well, no, you get some every week up to week 10. Some of them will have 2 exercises. If you don't care about the additional exercises, you've got to week 12 to complete them though. I'll get to the books in a moment. The third assessment task are additional exercises. Right? So these are basically extra lab ones that are harder. So it's just, are you better? Do you want to get more than just a pass? Are you better than that? Do these ones and you get a mark. Apart from completing the required lab exercises by week 10 to have the additional ones count, everything's due by week 12. So there's no real mid-semester deadlines or anything like that, but we'll have stuff going through it. There are 12 weeks in total. So there's a question, is there a benefit in getting higher marks? It depends on what you want to do, right? So getting just a pass in everything gets you a degree, right? But you do get recognition for doing better. So you get your degree with various levels of recognition of doing quite well. If you do really well, you might get the university medal, for example. So that's basically the best person in each it's not exactly degree program, but sort of subject area. So if you've ever seen like American things where they graduate summa cum laude and stuff like that, UTS has a similar thing. So if you get a higher than a distinction average, you get a little thing on your degree that basically says you did well. The other thing the GPA can affect, so that's your grade point average, or your WAM, which is your weighted average mark. They're not exactly interchangeable, but they're kind of similar, is if you want to continue to other study. Yeah, so if you want to do honors, so if you're in the biscuit and you want to do honors, or any other degree and you want to do honors, then you need to have, I think, 75% GPA. Don't quote me on that. Like, if you're interested in that, look it up. So the additional exercises will be in the labs when they're available, but they won't start till later because they're significantly harder and they'll just freak everyone out at the moment. Yeah, so if you get a really good degree and you do honors and get a really good honors thing, you can go straight into a PhD, which is true in Australia and England, New Zealand, a good chunk of the rest of the world, actually. Yeah. So all the assessment tasks allow any number of attempts. There's no restraints on that. And everything will be in Ed. Okay. So one last thing, we'll have a look at the subject outline because there's a couple of important things and this will maybe help answer the book question. I've lost the change share link. So the subject outline is back on Canvas. So as I said, almost everything is going to be on Ed. Canvas is still important because it's that kind of our official repository of important things. So there's two main things that are going to be on Canvas: the subject outline, which is an official document, and your official marks. The marks themselves, I probably won't get to putting them into Canvas until towards the end of the subject because I won't be able to collect them until towards the end of the subject. But don't try and add things up. Well, I mean, you can add things up from Ed and ask questions, but don't try and add things up from Ed and expect that to necessarily be the correct thing. Check what it is on Canvas when we get to that point. And that's like, if you have to challenge it, which hopefully none of you do, that's the mark that we'll be working off. Okay, so the subject outlines there, that's got a lot of important things. Please do go and read it. It gives you an idea of what you should be able to do at the end of the subject, which is basically build fully functional, usable, small programs. That's kind of the, if you get a pass, you can build programs that do simple, useful things. You may not be able to build a huge, world-conquering app or anything like that, but you might if you try really hard. It's got a rough outline of what's going to happen each week. This is, of course, subject to change a little. We usually do pretty well at sticking to it, but if we need to spend more time on something, maybe we will. If we get through something quicker, maybe we'll get ahead a bit. It's also got the due dates and a bit more details about it. It's got the details of the assessment tasks. So I have to stick to those because I've told them what they are, unless there is a significant reason for variation. So, for example, last year when we had the pandemic, we made a big variation to all of these. We're set up for it now, so there's probably not a big change, but say something else terrible happens, because that seems to be the way the world's going, we'll release an official document which says something about the changes. So it's got the requirements for passing. And the other thing it has is thanks to Raymond, who used to run the subject, a rather extensive list of useful textbooks. So if you're the sort of person who works well from a textbook There is a very, 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 very large number of introductory programming textbooks, a very, very large number in Java. Obviously, not all of them can be good because just statistically, some of them will be terrible, but most of them are good enough. The ones listed here, so Raymond's went into a significant amount of detail, sort of saying what exactly each one is aimed at. I left mine at home, but my particular recommendations, one I found good in the past is, oh yes, Head First Java. The Java in here is technically speaking a little out of date. So this only covers up to Java 5, but almost everything in this subject is already in Java 5. We're not going to do any of the fancy functional aspects of Java or anything like that came in Java 7, 8 up to 11. Yeah, so one thing with the Java versioning numbers is that they changed the way they did the numbering. So they used to release a new numbered version kind of when they felt like it. Now that Oracle's got it, they basically release one every year. And they just switched from numbering it sequentially to numbering it by the year. So the version numbers don't always tell the complete story there. But there's basically 3 big landmarks in, apart from the initial one, there's, let's say 4. Java 1. Oops, drop that on the spacebar. Oh yeah, here's the rest of the books, by the way. In the references, there's a whole bunch of other ones that you can get. There's, yeah, Java 1.2 was a big shift. Java 5, Java 8, and sort of Java 11 were the big ones. Now the OpenJDK project has taken over. There's not so many like gather all the big features and make one big release thing. They come out in stages now, so it's a bit smoother. How many years has Java been running on 3 billion devices? Quite a while. Java's everywhere. Yes, I am on campus. The other last thing I want to say while looking at the subject outline is to bring up the least fun part of this subject, which is plagiarism. I don't overly like talking about this, but it is a thing that happens and I would prefer to attack it at the start. This subject is, unfortunately, I don't know, a target for a good amount of copying, I guess, or a bad amount of copying, depending on how you look at it. So I think last semester, so spring, when the subject is slightly smaller, about 70 odd people got caught copying. Now, the thing that I want to say right at the start, and hopefully everyone gets this into their brain, is that the copying in programming, so it's not worth it anywhere, but particularly when you're learning to program, is really not worth it. It is super easy to detect, right? By the end of probably next semester, you could write a program which does the detection for you. I mean, yeah. Technically, Aaron has sort of the right answer, but yeah, it is incredible. The problem is it's incredibly easy to get, not the problem. I mean, it is incredibly easy to get caught, right? And the amount of effort you have to go to not get caught, you would spend less effort actually just doing the work. Right. Now, the big problem with that is that once you're caught, you go into an administrative process. That process can take up to 1.5 years to resolve. All right, so it's not like you get caught, you get a slap on the wrist, and you move on. You get stuck in first semester, first year for another 1.5 years. And it really, like, you know, if you're a local student and you wanted to spend 1.5 years doing nothing, okay. But the vast majority of the time, it would have been better to not submit anything at all because you'll get exactly the same mark, but not go through the administrative process, which puts a big line on your transcript which says, caution for academic misconduct 1, 2, 3 times, 3 times, and you're out of the university. So watching the chat go by, this does not mean that you can't use Stack Overflow. It depends on what you do. If you're using someone else's code to solve your problem, you're doing it wrong. If you're using someone else's advice to understand what you should do to solve the problem, then you're okay. I know that's a bit vague. As you learn to program, that will become clearer and clearer. The other thing is, I noticed already that someone claimed, there's only a couple of ways to program something and a lot of them will look the same. That really isn't true. Every programmer develops their own signature style, and it is surprisingly easy to tell when a piece of code is identical. It's sort of like a voice. Like if it's a tiny piece of code, okay, so the first week lab, there is one answer, basically. You can do some stupid stuff, but there's basically one answer. For anything of any reasonable length, it's going to show up how you code. So the question for today, what if I can't understand a problem, see others code and finish it myself with some similarity? Is it still plagiarism? That's a pretty borderline one. If you copy their code, it definitely is. If you kind of learn from it, it's not really. But the thing to avoid there, the thing basically here is don't read anyone else's code for any of the assessment things. And don't get anyone to explain code to you or anything like that. You can talk about the problems, but don't do the actual coding together. No, you won't code in BlueJ, it's all in Ed. Okay, so the last thing I want to say about the plagiarism is that from my practical experience of it, the main actual cause of plagiarism is that students get into difficult positions where they get stressed and then they make bad choices. Again, like I said, once you're doing that, you're almost certainly going to be caught and you're going to get at least 0 for the assessment task and maybe a worse penalty. So if you find yourself in a position where you're considering copying someone else's code, just come and talk to us. There are things we can do. If you're in a position where you're under enough stress that you don't have the time to learn something, so if you're just lazy, then okay, there's not much we can do. But if you're in that kind of stress, there are things that we can do to help. It may not be to fix that particular one, but we may be able to help you get back on track. Okay, so grabbing some of those other questions. So that's all I want to say about plagiarism. Don't do it. It'll mess you around for at least a year. The process is incredibly slow. And almost every other option is better than copying. I have never seen a false positive for plagiarism. Yeah, in theory, it could happen, but I've never actually seen one. I've seen some very complicated sets of plagiarism where the two people didn't know they were copying off each other, essentially. So, for example, once someone paid someone to write an assignment and that person sold it to other people. So then a whole bunch of people had exactly the same assignment, all thinking that they had a unique one still written by someone else, so they didn't do the work. But, when you're paying someone to do something in Australia illegal, then yeah. Also, everyone doing the, you wouldn't steal a purse thing, go and look up the Black Books piracy warning video on YouTube. So, yeah. All right. Okay, so there's probably a few questions I missed there. Like I said, there is a chat question thread in Ed, where you can post all these questions. Which I haven't been keeping track of. Yeah, so if you go to the lecture material, week 1, you can post questions there when it loads, and I will then, if I miss a question, you can put it there and I'll have more time to answer it. Or if it's worth keeping for posterity, please put it there. The chat on this thing screams past, so it's really hard to spot questions. You don't have permission. Okay, that is a problem. Hang on. Edit. Now you have permission. It's a problem with keeping them hidden until the thing. There we go. All right. Yes, please don't spam Pog. Ooh, so I can resolve one question. There we go. Okay, so websites or services for learning Python Java. So basically, really not a useful question. I've found Codecademy reasonably okay. It actually has things so you can learn. HackerRank is useful, but not until the point that you can actually code stuff. It gives you a lot of practice things, but it doesn't really teach you anything. It does have like learning ones, but they're not that great. Yeah, so when you get to DSA, HackerRank is a bit more useful. That's not to say you shouldn't start. It does have some like basic level ones that are still quite useful, but maybe give it a couple of weeks. The other one that I've forgotten the name of that has the weekly challenges. It's not Learn to Code. I'll try and remember to post that. Yeah, everyone post all the answers. Almost all. And with a lot of things like this, almost everything is worthwhile if it works for you. Right? It's hard to predict which one's going to work for an individual person. So just try them out. Like, you're not going to unlearn Java by doing it. Bookmarking Stack Overflow is fine. Everyone uses Stack Overflow. There's nothing wrong with that. The plagiarism thing is detected by code, but reviewed by me. So I can filter out some cases where it's borderline and stuff like that. Yes, we're just using Java in this subject. Yes, everything will be in Ed, but you do not have to, if you know how to use an IDE that you prefer better, you can quite happily download the stuff from Ed, do it in the IDE, and re-upload it. So most of the stuff here, so if it's not explicitly labeled as the something lab, it's to be done outside the labs. So the question was the week 1 getting started, do we do it outside the lab or not? So most of that you should do before you get to the lab. For those who want to switch over to Programming 1, you should just be able to enroll. If you can't just enroll, you can e-request into it. Like I said earlier in the thing, though, you're actually getting a good chunk of the same material here. You're just not getting the Python parts and some of the more complicated ones. And you will get the lectures as well. So you'll see I'm giving the lectures. So once they're available, you'll get them here. Obviously, you're not going to get the introductory lecture because that's irrelevant. I think there was another one. You don't have to download anything for this subject if you don't want to. If you do want to, downloading Java is easy. I suggest the OpenJDK You can get the Oracle JDK, but it's a bit of a pain to navigate through the thing to get the free version of it. It is still free. Don't pay for the Oracle JDK. You are not a company. You don't need to pay for it. It's still free. But yeah, look up the Open JDK and get the latest version of that. For IDEs for Java, I quite like Eclipse. It has its pros and cons. I don't particularly like NetBeans. VS Code is pretty good. And IntelliJ is also pretty good. Again, it's one of those things where sort of different ones suit different people, and you should try them all and find the one that suits your style. If you haven't programmed before, IDEs are probably a bit scary to look at to begin with. They're not, you can avoid most of the complication, but it throws a lot at you very quickly. So they could freak you out. To answer, I think, another question, yes, Ed already has Python and Java in it. And when I finish answering this, we're going to do some Java in Ed. Yes, it's up to you to keep track of when to do assessments. You're adults now. You run your own lives. I'm not your mother. I'm not your boss. I am your teacher, but not a high school teacher. That said, I will still point things out. I'm not going to leave you alone. You're not off by yourself. I am here to help you learn. But if you don't pay attention to any of your emails or anything like that, there's nothing I can do about it. I mean, even literally, legally, you're adults. If you want to ignore everything, that's up to you. Mother Dr. Luke. Yeah. Yeah, okay, that's fair. Some of you are still minors. I may need a permission slip for you. Should you disable code completion in an IDE? No, not particularly. If you're really keen on being like a competitive programmer, or if you really want to internalize it, yes, disable the code completion, and then come back to it later when you're a bit more familiar with everything in there. So for example, when I'm learning a new programming language, I tend to do it just in a flat text editor, because I have to actually type everything out then and learn it, rather than do it in an IDE. There is no final exam in this subject. We got rid of that. You have to do some of the pre-work before the lab. So if you see, so I think I've still got this one shared. If you see a little padlock on the thing, there's something that you have to complete before it. And if you click on it, I can't because I can see everything. If you click on it, it should tell you what you have to do. I think, yes, I am also the lecturer and course coordinator for Programming 1, so I'm running both at the same time. So my voice will be pretty ragged by Friday in week 7. Doing LeetCode through the subject might help. It depends on where you're up to in your programming career, or your programming learning career, I guess. It's a lot of these are kind of tricky to answer because it really, really depends on the person. The assignments are, strictly speaking, they're not open book, but we've got people doing them at home, so it's a bit hard to justify that. Difference between an IDE and a text editor. An IDE is short for integrated development environment. So it has a way to compile and run code, and often a bunch of other features like static checking, bug debugging, version control support and stuff like that built into it. A text editor just opens a flat text file and you can edit text, and that's it. Oh yeah, so just to go through so everyone can see the subject outline now? Yes, good, okay. So just to reiterate the assessment tasks, there are 3 assessment tasks. 2 of them are made up of lots of little subparts, but there are 3 tasks. Where are we? So they're all individual as well. There's no group work. The assessment task 1 is the required exercises, the pass-fail mastery tests. Probably not the best name there, but basically every week from now until week 10, you'll get 1 or 2 exercises that you have to complete. If you complete all of those, none of them are particularly hard either. And you get like, there's not like you have to do it that week. It just appears that week and you can complete it as you can try it as many times as you want. If you complete those all by week 10, then you will pass the subject and you can do the additional marks. You can't see my screen. Oh, why does it keep jumping to that? Weird. Yeah, so you'll pass the subject and do that. If all you want to do is pass, you only have to complete this assessment task 1, and that's it. So is the screen sharing working again? Working? Okay, good. It seems to be very finicky today. Okay, so if you do complete those by week 10, then you can do the additional lab exercises. So these additional ones will start appearing before week 10, but not quite yet because they're harder. And they give you some extra marks, basically. The other part is the assignment. There's no other conditions on the assignment, so you can do that as well, even if you haven't completed the other ones. And it's just a bigger block of code, basically. No, you do not have to complete the week 2 lab by Monday. You do the week 2 lab in the week 2 lab. The URL for the lessons, go up to the top right of Ed and click on the lessons bit. There was an actual useful question in here as well. Where did it go? Yes, so you can pass the subject by complete. It's not one single task. It is one group of tasks. So it's more than doing one thing, but it is all together under one umbrella task. Oh yeah, when do you get feedback? So you get feedback every time you hit mark. So it will tell you whether it's right or wrong, and to some degree of precision what you got wrong. So usually it will tell you what it expected to see and what you gave it. And I mean, it's kind of up to you to figure out the difference. Can you have a better grade if the code is neater? No, we don't get that far in this subject. There are marks for that in data structures and algorithms, or at least there were when I was running it. So we don't expect you to get to that, to have to worry about that yet. Are Eclipse and IntelliJ both lightweight IDEs? No, Eclipse is definitely not. I think IntelliJ is better at hiding how not lightweight it is, but it's not lightweight either. So Eclipse, IntelliJ, and NetBeans are like full-blown IDEs. VS Code is fairly lightweight, and the built-in IDE in Ed kind of borrows from that. Yeah, so effectively the assignment 2 mark is based on the test cases. So it's about getting working. At this point, what we want you to do is get working code, not magical perfect code. No, you're not supposed to know what an IDE is. Just a bunch of people pay for. Atom is fairly lightweight. It is not really a full IDE. You can kind of trick it up into being one, but yep, all the assessments are on Ed. Don't worry, everything's on Ed. If you live in Ed, you'll be fine. Okay, what time is it? Okay. Yeah, it just takes you to discussions first. You just, sorry, I'm answering a private question. When you click on Ed in Canvas, it takes you to the discussion. You just go in the Ed navigation and click on lessons, which I'll show you right now because I want to program something, because that's what we're here for. Oh, wait, I've already sharing that. Why does it keep dumping to the desktop? Right, so the Ed navigation is up here on the top right. So it starts off in discussion, and you can just go to workspaces or lessons, and that's all you guys can see. Okay. Okay, I'm going to move this down here because it seems to like doing that. That can go up there. You can go up there. You can stay there. Yeah, you can use anything to write your code if you want. You just have to submit it through Ed. No, don't use Apple stuff. Okay. That's not what I want. Wrong button. Cybersecurity, I'm not sure. It might be worth doing programming one. Okay, so what you can now do that I've made that public in Ed, if you go to the workspaces section, you'll all be able to see a public workspace that you can jump into. At the moment, it's read only for you guys. So you don't need to watch it from my screen share anymore. That's just there for the recording now. You can see it streaming through Ed at a much better bit rate. So it's much faster and nicer and doesn't ruin your data caps. So let's actually program something. I think I've answered all the boring questions about the subject. If you missed the answer to that, go back and watch the rest of the recording. Okay, so let's talk about Java a little. Thank you for drawing on the screen. Java is a mature, object-oriented, imperative, full-blown enterprise-level programming language. That doesn't mean you can't do small things with it, but it does mean that you're going to see a lot of the things that make it an enterprise language and go, why do we have to write this? We could do it in Python. It's much simpler. The difference is that Java scales to much, much bigger things than Python does. People will use Python to do big things, but it's not a crash hot idea. So what does it mean to be an imperative programming language, which Java is? So there are basically two sort of styles of programming language. There's actually more, but there's two major ones. There's imperative and declarative. You probably won't touch declarative for a while if you get there at all. You can actually do, so you can do functional programming in Java, which is a subset of declarative. But functional and declarative programming works by sort of specifying so this is not going to make a lot of sense, the sort of type level structures of things and what the input and the output should look like, and leaves how to actually do it up to the compiler or up to the environment that it runs in. Imperative programming, which includes Java, C, C++, Python, a whole bunch of other ones, works on you telling the computer what you want it to do exactly, which is why it's often simpler to get into. So one of the key ideas in imperative programming is the idea of state and variables. So state in imperative programming is basically summed up by what condition is every variable in the program currently at. Like if you get all the variables together, get all the memory that it's using up, what are all the details? And the way imperative programming works is by manipulating that state, i.e. creating variables, storing data in them, changing that data, and passing that data around. In a completely non-useful way, that's what imperative programming is. It's about passing data around. And that data is stored in things we call variables. So what's object-oriented programming? So object-oriented programming is essentially an outgrowth of imperative, then procedural, then object-oriented programming, where we have this composite concept of what a variable can store. So if you go and look at C, variables can only store simple data. They can store a number or a string or a reference to a piece of memory or something like that. In things like C++ and Java, most variables end up storing some simple data plus a reference to a piece of code which gives information on how to operate on that data. You can take notes on this if you want. This is actually all in the introduction to Java thing. Yes, Java is the language we're going to use. The main subject is programming, but Java is the language that we're using. Now, having said that, we're not really going to get to the object-oriented part until a bit later in the subject, and we'll only see it briefly. But because it's object-oriented, that's why we see things like this. So in Java, because it's strictly object-oriented, basically everything has to be in a class, and a class is a template for an object. Again, that's not going to make any sense at the moment, but keep that in the back of your mind. Yeah, C# is very, very similar to Java as well. C# and Java are both basically answers to the question, we hate this stuff in C++, can we do it better? The difference is they disagreed about which stuff they didn't like from C++. Every Java program you see will have this line somewhere. This is called the main method. Again, eventually we'll get to explaining what that is. But this is the one that gets run when you start the program, essentially. This is the piece of code where the program begins. It has a very fixed form. It always looks like that. As you do your exercises, you'll see it over and over and you'll get used to it. So the ones in purple are keywords. So these are words that the language recognizes as having specific meanings. So again, we'll get to we'll get to all of these eventually in more detail, but public means that everyone can see it. Class is the keyword to tell it that you're defining a class. Static is more complicated, but basically means you don't know what an object is yet, but you don't need an object to use this piece of code. You can just use it from anywhere, anytime. So stuff where you do need an object, you can't use it anytime. You have to create an object and use it, or take an existing one and use it. Void means that this doesn't produce a result. Again, something we'll get to later. Main is the name of the method. And this is the argument to the method. It's, again, a thing you don't know yet, but this is an array of strings, and it is called args. So args is just the name. So static means, you're not really going to get what static means quite yet. We haven't got far enough to explain that properly. But roughly, it means that you can use the piece of code that I'm about to write from anywhere in this program at any time, right? There's sort of no restrictions on when you can run it. If something is not static, so I can write, if I wrote another method here, I can create a method here so it doesn't have the static keyword. To actually run whatever code I put in here, I have to take some extra steps to begin with. Yes, there already is more information and an explanation in Ed. And there will be more as we go along. Don't worry, we're not here to trick you. Just I know a lot of you, this is one of your first subjects in university. we're here to help you. We're not going to just dump you into something and say, off you go, do things. We're going to lead you through this step by step. So just relax a bit for the moment. Don't worry. You'll be fine. Okay, so that's a bunch of gobbledygook at the moment. Yeah, this is a bunch of gobbledygook at the moment. And until a couple of weeks in, you can kind of just treat this as a magic incantation. This is a thing that we need to, something like this is a thing we need to do to get a program in Java to run. You may or may not vaguely understand bits of it, but for the moment, all we're going to focus on is stuff that we're going to write in between this open brace and this close brace. So once we get in between those open and closed braces, Java is essentially a procedural programming language. I mean, it's not really, you can still do object-oriented stuff. But what you do in here is you pass information around. You change information, you mess around with it, you print it out, you do things. So again, for those who, so there's obviously more in the lecture than sitting here, go to Ed, go to Workspaces. So up in the top right here, there's a Workspaces thing, and join the workspace. It'll be much easier to see than trying to watch through the video stream. What do I call it? Simple. So here is a really dull program that prints hi out to the screen. Again, here's our magic incantation for getting something to print out in Java. This line here is compiling Java from the command line. You won't need to do that through the subject. You can, you have the option of being able to do it, but you don't need to. So don't worry about this too much. And this is running a Java program from the command line. Again, you'll have the facility to be able to do that, but I'm not going to expect you to do that. At least not maybe until the end of the subject. Okay, so if we take for granted that this thing prints something out, so this is print with a new line at the end of it. Oops. Don't have to worry too much about what system.out means. Let me just close Discord. And it takes whatever's in these parentheses and prints it out. So what is the thing in this parenthesis? So this is a piece of data. It happens to be in Java of type string. So Java is what's called a strongly statically typed language. So that means every piece of information in the program has like basic, well, it has a type. It's called type for a reason. But more importantly, every variable also has a type. So I can make a thing called a string, which is just text, really. And so this variable, so this here is a thing called a variable, has a type, which is string. And I can assign, so this equals is the assignment operator, this value to it. So instead of putting hi directly in here, I can put that there and compile and run it. And outside, it looks exactly the same. So this bit here is the thing that tells Java what the type of this variable is. So this bit here is just a name. I can call this. In general, you should write descriptive names to the variables that tell you and other people what they do. But there's no compulsion for you to do this. This can be any old nonsense. There you go. So let's just focus on this one on line 4 here. This is at a fundamental level, the core action of anything you do in an imperative programming language. Ridiculously simple. You create a variable, which is a place to store information, and you store information in it, and then you do something with that information. With things like Java, so what I'm about to say is true of Java, C#, C++, to some extent C, but it's a bit, you can kind of fudge things there. And almost every functional language, you have to be explicit about what sort of information you can store in that variable. So I can't, or this might actually work. I shouldn't be able to just store a number in that because I've said that this variable is going to be a string. So again, a string is just the name for a piece of text. So you can see when I do that, I get an incompatible types error. So I've taken this thing, which is a number, and I've got this variable, and I've said that this variable needs to be text. And I've tried to put a number in a box that only takes text. So Java complains about that. And this is as I just mentioned in the chat, this is what static typing is. You don't need to know that keyword, but that's the proper name for it. And Java is very, very strict about how you do that. It has a lot of, well, they're very simple rules, but it has a lot of rules for what things you're allowed to store in what variables. Yeah. So if I wanted to use a number, I have to change the type of the variable. So our basic numeric type in Java is called int, which is short for integer. And now it works fine. So again, notice I didn't change POG there. That's just the name of the variable. And again, I can call this whatever I want. Of course, I have to change that everywhere. Fortunately, it has auto-completion, so I don't have to type out the silly nonsense that I have. And it works fine. Oh yeah, so Java capitalization matters. It has to be the same as whatever it was you said. No, this is a thing that will take a while to wrap your head around. In fact, just to kind of scare you, I have sitting on my desk a paper. Let's see if I can get the name there. Some difficulties of learning to program, which spends about about 10 or so pages talking about how hard this is to understand. Where can you find this? I can put this paper on Ed, actually. It may not make any sense to you, but I can put it up there. Okay. So, but at the moment, even if you don't understand it, and I don't expect you to necessarily understand it at the moment, you've seen a big chunk of the basic operation of Java. We do a lot of stuff in Java by changing the type. So this int here happens to be the type of this thing, of this variable, and assigning values to it and then doing something with it. So there's lots of different types in Java. In the intro to Java thing, I think I've put down all of the primitive types. So Java has two types of types. It has primitives, which just store simple data. And it has reference types, which store object data, but we won't get to objects quite yet. So don't worry about those at the moment. that's as far as my memory of pi goes. So int is our whole number data type. Float is our decimal number. It's technically a floating point number. If you want to look up what's the standard, IEEE 1154 or something like that, you can understand everything you want about floating points. You really don't do that. That's probably not the right number either. But basically a float is a way of storing decimal type data. We have a long, which is just, it's still just an int, but I can store bigger numbers in there. So let's see if I can remember how big I can make this. Why is it complaining about float? So I did the same thing. How is that a lossy conversion? Fine. Shut up. Explicitly make it a float. So these data types, so int, long, float, have certain limits on them. Eventually I'll find it. So here we go. I've got, what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nines. That's actually quite significantly bigger than the biggest number. But this can't be stored in an int. So an int is a 32-bit number. So as just came up in the chat, these are all just bits eventually, because all the computer actually stores is bits. And if you create an int, it allocates 32 of them to store the information that you want to store in there. So in a way, what the type is how to interpret a certain chunk of memory, what it means. But if I take a long, I get a 64-bit integer. So the proper name of a long is a long int. So I'll do that there. Still too big for a long. There you go. But that compiles happily. So float is similar. It has a bigger one, which is called a double, which you already saw it complaining about. So a float is a 32-bit floating point number. A double is a 64-bit floating point number. And pi is already defined because I can't use the same variable name twice. There it is. Simple. Yeah, occasionally like click on something in the workspace or it'll close. You can just reopen it again. So here, and our basic text type is called a string. A string does not have, well, technically it has a limit on the length, which is 2 to the 32 characters, but it's pretty unlikely you'll reach that. Oh yeah, don't worry. You'll be lost at the moment. That's all right. Expect to be there. Oh yeah, so that's the other thing about Ed that comes up. You may have noticed I'm not saving anything. It basically saves every character. Let's have the replay. So this is one of the advantages of doing that. You can watch me progressively type this. So Ed actually stores all the stuff there. So you, as long as your internet connection is up, you don't lose anything, which is nice. Yep, all the labs are through Ed. So if you're on an online lab, it's Ed and Zoom. Okay. So again, you're almost certainly confused. That's all right. Don't worry. The replay is for the workspace is up here, top right. But what we see here is a whole bunch of what's called declarations of variables. So every variable declaration has, finishes at 6:30. Sorry, we're 5 minutes over. Give me a couple more minutes to do some basic things, which will get you through the first lab. This won't normally happen because we don't have the administrative junk at the start. You have a type. You'll learn more types as you go along. Eventually, you'll start creating your types, your own types. A variable has a name. You can assign things to it. So this is the assignment. It works right to left. I don't know if I'm mirrored in the thing, but it goes right to left. So the thing on the right goes into the box on the left. And then it can have a value. It doesn't need to be this simple. Oops, let's not accidentally drag stuff. So I can make this. It can be the result of an expression. And you get information out that way. So this is basically programming. Every statement, one last thing. So this is the last thing I'll really talk about. Every statement in Java ends in a semicolon. That's how Java knows that you finished typing. Well, you finished that piece of code. So if I leave that off, you will see this error. Semicolon expected. And it tells you where it thinks it probably is. You're going to see that error a lot. Don't worry, everyone makes it all the time. If you're paying attention, I made it before myself, and I've been programming in Java for, what year is it? 22 years now. So everything that I've just done there, which is both not much, but also desperately confusing at this moment, is enough to get you through the first lab. So what you can do now, if you want, is you can go to this thing and you can fork it and start working in the workspace. So you can start from what I've done and create a copy and work from it. You can create your own workspaces and mess around. Or you can just get on with the labs. Okay, so that's, if you've been paying attention through the whole thing, that's everything that you need to know. I'll just answer quickly some of the last few questions because they're kind of important. So that one, is there anything you need to do before next week's class? Yes, you need to read. Oops, I went too far back. That is the wrong year. You need to read Basics of Programming and Introduction to Java. If you want to start, yeah. So if I give you any code, that's free game. You can't get in trouble for copying my stuff. I'm giving you that to you for free. Yeah, hang on. So read Basics of Programming and Introduction to Java. That's in the lesson section. That'll unlock the week 2 lab and you'll be ready. There's no tutorial this week, which is why I'm not too worried about running over. Yeah, so if I give you code for the assignment in class, you can copy it. That's free game. If you want some practice before doing the lab, you can do the warm-up exercises, but you don't need to. So those 3 exercises there are just repeated in the lab anyway. So if you don't get to them, it's not a huge problem. There is, I think it's worthwhile doing this. So after what I've just shown you with the variables, this if you can get through this, this will start helping you think about how data is passed around between variables. Yeah, so do the yellow ones if you can, but you don't have to. So then next week in your lab, you'll essentially go through these. So your tutor will help you do some of them, probably try and get you to do them yourself, and then maybe share some of it. And you have your first required exercise. This one is incredibly simple. They're not all this simple, of course, but that's about it. For those who want to change to programming 1, there's not going to be a major difference in the first couple of weeks. So you'll probably get switched over before it's an issue. If you're still not, if you've already put in an e-request to switch over and you're still not switched over by the end of week 2, send me an email and we'll do something. The volunteer drop-in set. Oh, yeah. So there's one last thing that I really want to get on this recording. Programming Fundamentals has UPass sessions. And these are really, really useful. The recording will be on Ed. Everything will be on Ed. While this is loading, I can answer another question. Python is not better than Java. Java is not necessarily better than Python. I have a personal preference for Java over Python, but they have different use cases. So Python's better. Like if you're doing a short scripting thing, you do it in Python. Otherwise, do it in, if you're doing something big, you do it in Java or C++ or whatever. Or if you want it to be fast, you don't do it in Python. Okay, these orange ones here. There's 1, 2, 3, 4, 5, 6 of them. These are what's called UPass sessions. They won't open till week 3, but you should get an email soon about, you want to see my timetable? I'll put my full timetable up in a sec. But you should get an email about the UPass sessions soon. These are separate from the subject administratively, so I don't have anything to do with it. Whatever you do in there is between you and your UPass leader, so it's all private. Like it doesn't affect your mark other than that you learn stuff. Like they're not going to report back to me and say, oh, this student was terrible or this student was great. It's just practice. It's a friendly environment. It's with people who've done well in the subject before, so they know what you need to do to not just pass, but do well if you're aiming for that. And like anything, practice is really the key to learning to program. It's not a thing, you know, as you've seen with this bit already, it freaks everyone out. The way you get over that freak out is by practicing. If you think of, you can think of programming, this is maybe a bad analogy for, you know, a bunch of nerds learning to program. It's like a sport. You don't walk onto a basketball court for your first time in your life and expect to be the best basketball player in the world. You play basketball over and over again. So a place where you can practice Java is in those UPass sessions. It's in the weekly labs. It's in the extra material that, yeah, so like Wii Sports or something like that, or California Games if you're old enough to remember it. You can look up other exercises. There's a thing called Zybooks, which I think is listed in the subject outline somewhere, where it's got some learning material and some exercises. There's online practice things like Codecademy and stuff like that. Oh, there's a Nick. Hi, Nick. Is there somewhere you can download Smart? No, unfortunately. It is not mandatory to actually attend the labs. It is mandatory. Well, okay, if you want to pass, it's mandatory to do the required exercise, complete the required exercises. Okay. So the required exercises are assessment task 1. And that one that you just saw in the lab is the required one. Okay, that's enough for this week. You've already been way overloaded with information. Take a break over the weekend. Oh yeah, sorry, I'll show you the rest of my timetable. So I don't actually have to do all of these. I've got tutors to help. So this is the two subjects I'm looking after. I do not have to do all of those. Like I said, the Nick who just said hello privately, I think, used to be a tutor. He's quite good. So if you find Nick Baptista and want to ask him some questions, he can help. Hopefully I didn't just freak him out. I don't think I can freak him out. Okay. And that's just my class stuff. There's a bunch of other things I have to do as well. So I'll close the anxiety-inducing timetable thing. Yeah, so with the thing here, if you want to look at the typing bit by bit, you can go top right, well, almost top right, the 3 dots, extra stuff, and hit the replay button. Whether you have the replay button on something kind of depends on whether you own it or not. So if you fork this, I think you should get it for the stuff that you type. And you'll have it on the things that you do. Yes, Nick, send me an email to remind me to do it later. So the information I want you to take away from today is follow the stuff on Ed, do the exercises, go to your labs, keep practicing, and don't freak out yet. Don't worry, learning to program is hard. Yeah, so you may or may not have the 3 dots on the workspace because I own this one. So if you create your own workspace, which you can quite happily create them, you should have the replay feature, I think. How do I run the code? So in this case, it's this line here. My email is in the subject outline, assuming you're talking to me. It's also on Canvas, and I think it's also on Ed. You can get me through Ed as well. Like if you you can put private posts on the discussion board. Oh, I'll look into the replay thing. Okay, so the weekly exercises are stuff you do in the class. At least one of them is required. It is not due at the end of the week. It's due by week 10, basically. And absolutely everything has to be completed by week 12. That's the end of the whole thing. I'm just entering now. So anyone who's got no more questions, we're done. You can go and have a break and have a weekend. I'll leave the recording on just so it's recorded for anyone who has to watch it later, thanks to the Zoom being a jerk. Thank you all for coming. Thank you all for the first one. Hopefully we have a better setup next week. For those who didn't make it, sorry about that. I had no idea Zoom had a limit like that. Never hit it before. Yep, don't worry. You'll like if this is the first programming you've ever seen, you're going to be confused. You're going to be confused for a couple of weeks at least. It's an absolutely normal state. In fact, I would suggest that at regular intervals throughout your programming lifespan, you will be confused, very confused. Completely normal. Don't worry about it. Don't panic. We're here to help you. How did this code output? Blah, blah, blah. If whatever I want is that, because longint is whatever I want times 2, and I'm printing out longint. Yeah, the times 2 there. So anyone who's doing software engineering or comp sci, you should probably be doing programming 1. Programming 1 does not assume that you have any knowledge of programming. They both start from a blank slate, but you guys are going to be hit with a whole bunch of programming a lot earlier because of your course requirements. So it's probably better to push yourselves a bit in the first semester to clear that hurdle a bit earlier. Oh, good there. The stream worked. Nice. Cool. Programming 1 does not run in summer. It doesn't run in spring either. So that's the only problem with Programming 1, because it's a bit more niche, because it's sort of aimed at a smaller section of the students. It only runs in autumn. So the tutors this year, Natalie, Crystal, Mitchell. I've written them about 20 times already. And Juan. Yeah, but you'll meet them all next week. Well, Nick might not, but he can come to class. Yeah, so Programming 1, we start with no knowledge in that as well. The only difference is we push a little bit harder in Programming 1. And yeah, tutorials, lab exercises, and discussion, and a place to do your required ones. So if you miss out on 3 weeks of Programming 1, you know you won't get super far behind. One thing is I'm going to put the labs, not the labs, the lectures from Programming 1 on the Programming Fundamentals. Thing. So you can follow along if you're intending to swap but haven't swapped over yet. Yeah, so if you're doing software engineering or comp sci, so comp sci you really should be doing it. Software engineering, I very strongly suggest it. Again, it's not the end of the world if you don't. So if you don't want to put that pressure on yourself right now, you're still okay doing programming fundamentals. It's just that instead of learning a bunch of stuff up front, that'll be spread out. So there'll be a bit more pressure next semester rather than this semester, if you know what I mean. So to the comp sci student who got the year request declined, tell them that it's a requirement for your degree. There should be room. Prog 1 shouldn't be full anymore, depending on, unless you all fill it up right now, because we managed to get an extra lab and more space in the thing. I don't know what that error means, because I can't see your code. If you're just doing a biscuit, what you want to, it's hard to tell because it depends on what major you do. So if you do the enterprise, if you know you're doing enterprise systems development or the data analytics major, or maybe the cyber security one, then Programming 1 might be better, but it's not as critical. So in the biscuit, you don't get slammed quite as quickly with more programming work. You can if you choose to. So the biscuit's more flexible. So if you're doing data engineering, you should be able to do Prog 1, but you've got to make a bit of an argument that it's an effective substitution, which I'm happy to support, but you should go and talk to your program coordinator about that. Yeah, so if you've got decent, if you're already experienced in Programming 1 is probably more interesting. It'll be a bit faster. Which Prog 1 classes do I teach? Lecture and one of the ones on Thursday. I can't remember which one. I think it's the second one on Thursday. There will be a lab class next week, but not this week. There are no labs in week 1. So don't withdraw from Prog Fun and enroll in Prog 1. Try and enroll in Prog 1 and then try and withdraw. If you can't enroll, then e-request. Yep. And that, unfortunately, is my signal to cut this off. I've got to go. I have a previous appointment. Okay. So everyone, if you've got further questions, put them on the discussion board. I'll talk to you all later. Nick, I will arrange so you can sabotage the workspace later. Send me an email. But right now, have fun. I'll see you all soon.